Hello everyone, welcome to the section Compute Options on GCP. My name is Osmond. I'm an enterprise custom engineer in Google Cloud team based in Vancouver here. Welcome to the section again. Today we will talk about the compute options within GCP. So we are talking about a journey between infrastructure as a service to platform as a service. We will talk about three kind of product set. One is compute engine, and then it's about the containers, and then we will talk about serverless runtime. First of all, let's talk about the compute engine. Most often we talk about we mention it as a GCE, which is Google Compute Engine as a short form. GCE actually is virtual machine running on Google Cloud infrastructure, where it provides various predefined or even customized VM family for you to use with a very with a very customizable pricing model, and also with a larger capability. But today we will highlight several capabilities or uniqueness with the compute engine. First of all, we have preemptive VM, we have bring your own license, we have sole tenant, we have live migration. All of these features, we will talk about it later on. Let's move on. We have prepackaged several product set or packages on the VM families. For example, we have cost optimized VM, which is named as E2 family. We have general purpose, which is N2, and with AMD's CPU, we name it as N2D. For example, we have compute optimized, which is C2 and C2D. Memory optimized with M2, and if you want to use GPU or TPU, then we have accelerator optimized family. We name this, which is prepackaged for certain predefined workload, where you can have better TCO, or have more flexibility, or you can run more workload on under each node. First of all, before we use the prepackaged VM family, sometimes our customer will tell us, "Hey, Osmond, I just don't like your prepackaged machine family because I just want to have 2 CPU but 180 gig memory by whatever reason." If you in other cloud you cannot do this, but in GCP you can do it without any hesitation. We offer custom machine type here. Just you select your machine type with 1 virtual CPU up to 96 virtual CPU, or even any even number between them. You can just use compute engine start-stop features to move your workload from one family to other family, or from one custom VM to another custom VM. We only price our resources by vCPU and memory. All those prepackaged VM family is just for your convenience. If you would like to have a very highly customized environment for your workload, you definitely can do it by your own. Next one is, when you run your workload on top of GCE, during the course, we monitor the utilization of your workload. We'll get insight about your usage. We will use our machine learning platform to optimize your cloud spending. So that's why, like the screen here, we will recommend that, hey, you can actually downsize your machine to a much smaller, so you can save more costs, right? So it helps you to avoid paying for idle or oversized resources. And you just click apply, and then we will convert your machine to a smaller model. Preemptible VM. What I discussed before is a predefined family and also customized VM, which is a long-term usage. But sometimes when you're running various high spike workload, like geometry, mathematical computational, data processing like Hadoop or Spark workload, or even Monte Carlo simulation, all this kind, you just need a short term of multiple VMs. So in order to save more costs, we actually use our Google machine and rent it to you as a preemptible VM with up to 80% less than standard pricing, which is very good. Preemptible pricing for GPU or TPU is 70% off the discount, and the local SSD is 40% But there's a trade-off, right? Preamble VM is actually Google-owned instance for internal use. When we have extra capacity, we rent it for a customer to use. So the maximum lifetime of that preamble VM is only lasts for 24 hours. So you can use it day by day. So another one is when we need that machine back, we will give you only 30-second notice. So this kind of workload is good for spike workload, and those workload can be rerunnable, restart again, right? So this is more flexible with 80% less price and with predictable pricing. Another one is about GPU. You can attach any type of GPU when that region is available. So you can attach VM, you can provision a custom VM with attached different kind of GPU onto your VM, and then we offer the pricing is based on per second billing. We also provide preemptible GPU too. So all this kind of virtual machine with GPU is good for machine learning, scientific calculation, physical simulation, or other 3D visualization. All this kind of thing is what we call predefined machine type, right? So this is very good. But when you want to switch from one predefined type to another predefined type, you have to use a computer engine start-stop features to move your workload, which means you have to stop the machine from, for example, an 8 CPU. When you want to upgrade to 12 CPU, you have to stop your machine. So bear in mind with this, when you want to switch machine type, you have to stop it. But another good thing with GCE is very flexible. We offer different kind of storage. For example, we have persistent disk, which is HDD, hard disk. From various size, you can automatically do encryption. You can provision up to 64 petabyte in size. And also, we offer a local SSD for high performance access. And you can also attach a cloud storage bucket, which is a very affordable object storage for your usage. And all this kind of usage, persistent disk is the regional specific, which means you can provision different location based on our region, and then provision different size of the storage for your environment. This one is live migration is a unique features within Google. When you heard about the meltdown, the CPU, Intel CPU problem, we help our customer to patch the instance and move their workload to other patched environment without any downtime, which is what we call live migration. This live migration is a capability for your system maintenance without any downtime. We can move your instance from an instance to another instance with the same configuration without any downtime. So that's why we call it live migration, which is very reliable for your infrastructure and without interrupting your workload. But we talk about general purpose, this kind of predefined package. We have custom model. We have different kind of storage. We can provision different memory. But how are we going to price it? First of all, we definitely can price you as pay as you go, which means you request the resources and then we price you based on the utilization of those resources on second billing, right? Which has no upfront cost and no termination fee. When you use it, we charge you. If you stop it, we won't charge you any CPU or memory usage. We just charge you for the storage. But in order to having more flexibility on the cost and the prediction or save you more cost, we provide a preemptible VM, which is stock lifted for 24 hours within 24 hours. But how about when I use the machine for longer term? We have one discount is called sustained usage discount. Sometimes we just use it as short form as SUD, which is when you use a preset environment or customs is a custom VM for longer term. For example, within a month, you use it for 1 quarter of the month, we will automatically provide you a discount. And when you use it for the whole month, we will give you more discount when you use it longer and longer. And then another type of discount is based on committed use discount. We call it cut. Is we offer you a very deep discount when you commit certain resources based on CPU and memory, not by CPU, not by version of CPU, but a CPU type. Which means when we upgrade our hardware, even you have a existing cut, you still enjoy this physical CPU upgrade. Sustained usage discounts when you use more than 25% of the month, we give you more discount. So up to when you use 40% of the month, we give you around 7 to 8% discount. When you use the whole month, we will give you up to 30% of discount. But sometimes you will question, hey, Osmond, I use my machine type I turn it on and off with multiple instances with a similar configuration. What can I do? We will aggregate all this kind of usage together and count as one go, which means you can on and off the machine with multiple machines, and then we will consolidate about a billion in the end of the month. Another one is about some customers say, my application, because in virtual machine hosting on the cloud, which means I'm sharing the hardware with the others. But certain application, for example, finance, government, or military application, they have certain requirements that their environment cannot be shared with each other. That's why we provide a solution called sole tenant node. When you create a VM, you have to provision. You mentioned you code it as a single sole tenant, which means we will hold the whole node for you. Of course, we will incur a higher charge. So in order to give you a sole tenant with the compliance requirement, you can host all your workload within a single tenant, rather than sharing the node with the others tenant within GCP. When you are running VM, a lot of people say, when I'm having my data center, I have my operation team, or I have a server administrative team to help me to patch the OS, apply security patch, do configuration management, do inventory management, all this kind. How can I do it on the cloud? We also offer a service called VM Manager. When you have less than 100 nodes, which is free of charge, we help you to manage all your OS, all your VM within your project. We help you to patch the OS. We help you to upgrade. Well, we opt to upgrade the software package. Well, we help you to do OS inventory management, all this kind of thing. So when you're creating more and more VM within GCP, it won't be like a mess. All of them are being up to the latest security patch and all are under control. Next, when we talk about GCE, which is virtual machine, right? Just a very native infrastructure as a service with CPU, memory, networking, all this kind of thing. You have the control. You have the VM, and you have the control to do administration on the OS level patches. You have create your application and all this kind of thing. But sometimes when people say, I just having a VM is huge because I have to manage all this kind of thing. But container is getting more and more popular. What is container? On the left-hand side, actually, is what we call virtual environment. We have a very big machine, and then we share it through using a hypervisor, and we run the VM within that hypervisor environment. So every VM will have their own guest OS, and then the library and the guest OS is not shared by each other, which incur, for example, in here in the left-hand side, when you do a OS upgrade or patches, you have to do 3 times. But in another way, in the right-hand side on the container deployment is every container actually share the same container runtime. The container only have a very self-contained environment, for example, with the library, and then we have another container stack on that base container is the application coding and runtime, which is good. Why it's getting popular? Because it helps you to deploy faster. It helps you to create an immutable infrastructure. All the container can be reused. Container and container between containers having isolation because of the container runtime is having a namespace isolation. We can do portability. We can do better versioning within container, because which is smaller in size and having faster deployment time, which is good. But what else? Container is actually making operation easier, and you can see with this by the time it's going, most of the core operation team is doing the same, doing almost linear work performance or throughput. But when you're running containers, which give much 10 times faster when we grow the operation team, because we can run container faster and we can do it more quicker under a management way. But when you run a container, a new set of challenge come back. For example, when you run a container, you have to think about how to manage the container relationship within container, how to do networking, connectivity, all this kind of, how you scale the container, and how you do deployment, how you do update, rolling update, blue-green deployment. When something happens, how you do discovery, how you do health check, all this kind of thing. All the administrative headache coming back again. Container is good, but doesn't give you certain benefit, but doesn't save all the problem. Google actually run containers for over 12 years. Everything within Google actually is containerized already. The service that you use, Gmail, YouTube, Google Search, all are running within container. We create container, and then we found out there is a pattern to how to better manage container orchestration. So we actually create Kubernetes, and then we donate Kubernetes to open source. That's why Kubernetes is so widely accepted within the market, because it's bulletproof, it's well tested within Google. And in 2015, actually, we offer a service called Google Container Engine, which is GKE, which is already available by 2015 August. Kubernetes actually is a container orchestration services. It helps you to do the scheduling, help you to manage container lifecycle, and help you to do health check. When workload actually spike up, it helps you to do scaling. And when you deploy container within a cluster, it helps you to do naming and discovery within that cluster. All this kind of thing is very, very good, right? For example, and you have to do logging, monitoring, debugging, all this kind of thing, which is good for developer and administration. But if you have to manage a Kubernetes by yourself, probably you will get into some problem, because it's another kind of mindset and principle and naming convention with this kind of new technology. When people adopting cloud, they do want to enjoy the benefit of cloud services, but they do want to offload the overall administrative headache, right? So that's why we offer Cloud Kubernetes Engine, GKE, which is the fastest, most cost-effective way of using Kubernetes, because it's a fully managed service of Kubernetes on top of GCP. Since we manage Kubernetes for so many years, we have a predefined best practice how we manage Kubernetes, how we manage container, and also we create a security hardened container optimized OS for you to run your workload within GCP. GKE actually is enterprise grade compliance for HIPAA and PCI DSS 3.2 compliant. We can do upstream and up-to-date Kubernetes access for the latest innovation. Most of the time, we just give you the latest version of Kubernetes and follow the whole lifecycle of the Kubernetes upgrade and roll out. So first of all, what is GKE? GKE actually is a managed Kubernetes, as I mentioned, but it do provide a feature-rich services here. For example, we encapsulate the management console, we encapsulate the cluster node, all this kind of thing with a very rich and powerful UI, which means most of the time you don't have to use the command line to manage the Kubernetes and also the worker nodes. You can use the UI to do so. We help you to do SRE or site reliability engineering monitoring. We help you to automate the repairing of the app, optimize the application. We have to do auto load balancing and auto scaling. We have a global virtual private cloud, which means we can hide the overall cluster within your cloud network environment, rather than give the customer a public IP address for which will introduce a kind of vulnerabilities or risks for other access your cluster, right? So the overall SLA for Kubernetes is 99.95% of availability. The overall fully managed Kubernetes provide the following best practice or benefit. For enterprise readiness, we can provide resource limit. We provide hybrid networking. Right now, GKE support multiple cloud environment, and Anthos is supporting hybrid cloud and also even on-prem with bare metal. The overall operation of Kubernetes GKE is so well proven. We provide auto repair. We provide OS build for containers only, and we provide security and compliance certification for all the environment. The developer experience is which is fully managed. We provide auto upgrade of cluster and worker nodes, auto scaling, horizontal scaling, vertical scaling, integration with other part of the DevOps environment, which is open source portability, which means it's 100% compatible with the open source version, because I know that other cloud providers do not do so. And we also offer a private container registry, which means you don't have to share your container image open to the public. So next one, we already talk about GCE and GKE. But I forgot to mention is GKE actually is based on GCE, which means when you create a certain kind of node and we deploy the cluster, the Kubernetes cluster on top of the virtual machine that we have within GCP. And then another portfolio is about serverless. Right now, a lot of people talk about serverless. So what is serverless? First of all, to us, serverless compute is around how you can provision or develop and deploy your application in a very fast and secure manner without managing all this infrastructure headache. You don't have to worry about the memory. You don't have to worry about the cluster size. You don't have to worry about how to do auto scaling, how to set up networking, all this kind of thing, because developer only focus on creating business value with certain kind of feature requests, right? So the serverless compute will have all this kind of capability, like auto scaling is fully managed, and it provides high speed to market. What is the benefit of serverless? Of course, I mentioned it again and again, you don't have to worry about the on-prem interconnectivity, physical server network, physical storage, or this kind of thing. Even on the cloud, when you have to run the compute engine, you still have to worry about the VM versioning, OS upgrade, all this patch, even though we provide the service, but you still have to manage it, right? For serverless, you only focus on application development and how to do performance monitoring and tune your application according to your requirements. You don't have to worry about all these lower red or yellow bricks with this diagram. So all the focus is put on providing value for your company. We can do a comparison, like when you are doing infrastructure as a service, like you are building your own house, you are building your custom house, you have control on and selection of your site plan, floor plan, what kind of appliance you want to buy, what is the fixture, when you want to finish it, the furniture, what kind of other small appliance, the look and feel of all this kind of thing, which is time consuming but flexible. Right, this kind of is called a custom house or for equals to infrastructure as a service. But when you do a serverless, just like you were doing a fully furnished service apartment, I just give you a requirement. I want 2 bedrooms, 3 bedroom, and then I just move in. And then when you move in, all this kind of site plan, floor plan, or furniture is all available. What you have to design is how you enjoy this kind of service and leverage this kind of service to enjoy your life within this house. But Within GCP, we offer a lot of service. Even we provide 3 different kind of serverless compute product within the portfolio. One is called App Engine, which is a source-based web application on fully managed environment, where you can host your web application. We just deploy your source code into that App Engine environment. Your application will up and running, auto-scaling to when the workload comes in. The next one is what we call Cloud Run. Cloud Run is another version of running serverless within a container. So which means you deploy your code into a container, but that container actually is running on a fully managed Kubernetes container environment. Another one is called Cloud Function. Cloud Function is an event-driven function as a service, which means that you only write a certain kind of snippet or code snippet. You deploy into the Cloud Function, you trigger by an event, and then you just run out the code and then you stop. So let's discuss when we need which one, right? So first of all, App Engine. App Engine is the first product within GCP. In the old days, Google very focused on providing a very ideal environment for developer to develop their application. That's why we create App Engine for a customer, where using a web framework that support HTTP routing and HTTP method. You just deploy your application written on Java, Python, Node.js, Golang, PHP, or Ruby. You can deploy that code and compile it into App Engine, and then the application will be triggered and run it to serve the internet. The web traffic requires very minimal latency because it almost real time. And you can deploy into a custom domain. The developer don't have to worry about the scalability problem or how the network set up, all the security things. We provide a runtime environment, the platform as a service, and then you just deploy the code into App Engine, then it will be up and running. The next one is Cloud Run. Cloud Run is you design your application and write your code, and which is designed to run in a container environment, which means you have to think about how to instantiate a container, which serve HTTP or HTTPS, and then, but since it is running in a custom container, that's why it can support any kind of language, because you can create the container, you can run the container with certain kind of library or languages you like, and then it's very portable because it's running on container. You don't have to worry about custom management because we just deploy the code within the container, and then we use that container image to do auto scaling. Okay, if your environment is not supported with Java, Python, Node.js, Golang, PHP, Ruby, or this kind of language, you have a very specific environment, but that kind of environment can run in within container, then you can just use Cloud Run. Okay. The last one is what we call Cloud Function. Cloud Function is a code snippet where you don't have to think about what is container. I don't care about it. I don't have to write the whole program like App Engine, because App Engine you have to compile the whole code and make it up and running. In Cloud Function, you just write a code snippet with just like a function within the language, and then it's a single purpose reusable code. Okay. Is tentatively the Cloud Function is not a long-lived function, which means not running for days or months. You just trigger by event. When the event come in, it will trigger the function, run through the code, process the data, and then return back the result, and then the function will terminate. It gives you retries, and it right now it supports Node.js, Python, Golang, and Java. Cloud Function is intended to do something like serverless Lambda things on the top of cloud. So here is the comparison for the serverless product. For example, when you're having a web or mobile app, you want to serve over HTTP, where you can use App Engine or using Cloud Run. It depends whether you want to run it in within a container, or you just want to deploy the code within the App Engine and without any hesitation. Next one is when you want to develop API serving a web, mobile, internal application, definitely you can use App Engine and Cloud Run. If you want to do data processing without any front end, then our recommendation is to use Cloud Run, because App Engine is serving the purpose of to serve the front end. If you want to just do the data processing, we recommend you to use Cloud Run to run it, because it gives you more flexibility, because you have more control on the container level. If you want to do automation, workflow orchestration, or even event-driven reactive automation kind of thing, you can definitely use Cloud Run or Cloud Function, because it provides all this kind of flexibility. But if you just want to connect cloud services with certain kind of functional snippet, sometimes we mention as a GroundSchool code, then which is designed for using the Cloud Function. For example, if you want to say, when I upload a picture into cloud storage and then I want to trigger a function to process that image, then we'll write a Cloud Function to process that image. Then when you upload it to the Google Cloud Storage, then it will send an event to the Cloud Function. The Cloud Function will trigger the image processing task for that image, and then it will terminate. When there's a large of upload, then we will just auto scale the Cloud Function to cope with the workload, right? So thank you very much for your time. In this section, I already described from the infrastructure as a service to the platform as a service area with the compute engine, Kubernetes engine, and Cloud Run, App Engine, and also the Cloud Function. Thank you very much, and see you in the Q&A. Thank you.